Alright, so welcome back. Today we're going to be focusing on lesson 33 from equations to inequalities. So remember, in inequalities, whenever we have an expression that has our greater than, less than, greater than, or equal to, less than or equal to. All of these are my inequalities. And an equation, remember, is whenever I have a left side of something equals a right side of something. And it can be used with variables or not. Our I can statement is I can understand that an inequality with numerical expressions is either true or false. So my base for a numerical is numbers. So it's saying I can understand an inequality is true or false. So here's my inequality with numerical expressions with numbers. So it's saying I can understand that an inequality is true or false when it has numbers in it. So we'll be looking at equations like these and saying what can we put in for y so that they're true? What can we put in for y so that they are false? So let's go on to our first problem. What value does y have to be true? And what value does y have to be false? Well, let's look. This first problem, y plus 6 equals 16. I can either know that y is going to be 10 or I can use my inverse. So I'm going to subtract 6, and I'd be left with y on the left, and 16 minus 6, that's 10, so I'd be left with y equals 10. Let's check. Yep, y equals 10, and then if I put any other number in for y, it's going to give me a false statement. Let's try 0. 0 plus 6, that would be 6. 6 is not equal to 16. So it's any other statement would be false, would be incorrect. Let's try our next one. Y plus 6 is greater than 16. Well, I know 10, if I put 10 in, I would get 16. 10 plus 6 would lead me to this, and then I would have 16 is greater than 16. Is that true? That's not true. 16 is not bigger than 16. So what that means is my 10 has to be a larger number. So my answer is going to be y is greater than 10. If I just put 10 in, it'd be incorrect. So that's why it has to be greater than. My false numbers is whenever I put a number that's 10 or less. And we can see why 10 or less works from this part right here. It obviously works if I put a number less than 10 in, like 0. That's 0 plus 6, that'd be 6. 6 is not bigger than 16. So that's how I get that false part. So let's look at our next one. Y plus 6 is greater than or equal to 16. Well, I already know this 10 seems to be a special number with this problem. So let's try putting 10 in. 10 plus 6 is greater than or equal to 16. Let's look. Is 16 greater than or equal to 16? Yeah. I know 16 is equal to, so I know y can equal 10. But what about if I pick a number larger? Let's try if I do 11. What happens there? 11 plus 6, that's 17. 17 is greater than or equal to 16. So I see my number can be 10 or larger. Let's check to see if that is correct. Yep, and it looks like it is. Y is greater than or equal to 10, and then my false is any other number that's not 10. So let's look at our next one. 3 times g equals 15. Well, I can do my inverse, divide by 3, divide by 3. I know 15 divided by 3, that equals 5, so I'm left with g equals 5. My false statement would be whenever g does not equal 5. So whenever g is any other number, it would be false. Okay, my next step. Let's look at when I have a multiplication with an inequality. I have 3 times g is less than 15. Well, I already know when g equals 5, it's going to be 15. So if I put 5 in for g, I'm left with 15. It's less than 15. Does 15 equal 15? It does, but 15 is not less than 15. So I know that g is going to have to be less than 5. Let's check though, just to be sure. If I put a number less than 5 in, So I'm going to try 4. Let's see if that works. 3 times 4, that equals 12, and 12 is less than 15. And then I know the opposite is true. If I put any number that's 5 or greater, it's going to be a non-true. 15 is not less than 15, so I know that's a false statement. So anything bigger than or equal to 5 will be a false statement. Okay, our last one, and then we'll go on to our next problems at a little faster speed. What can I put in for g so that 3 times g is less than or equal to 15? Well, it's very similar to what I had up here, only this time I'm going to flip. Or not flip, I'm going to change. Since I have my underscore here, I know that it can be g is less than or equal to 5. I know that less than there means now it's okay if I have 15 on the left and 15 on the right. That would be a true statement. So let's check and look at that. It is a true statement. There is one mistake I see for my problem up above. Does anyone see it? Yeah, the problem is I forgot my little underscore here for that equals to. So it should be g is greater than or equal to 5 would give me a false statement. Because remember, if g is 5, that's false. Alright, let's look at our next problem at a little faster speed. Okay, which of the following numbers, so my number list is right here, if any, make the equation or inequality true? Let's look at my very first one. It's pretty easy. I'm going to subtract, do the inverse from each side, and I'm left with 4 equals 8. 8 plus 4, that equals 12. 12 equals 12. I want you to look, though, how this answer is written. You'll see we have m equals 8, and then we have these little bracket things over here. What those brackets are for is whenever they give us a number set, they're telling us m can equal, or x can equal, or whatever variable can equal only these certain numbers. Then instead of saying m equals or variable equals those numbers, we actually list these numbers inside the bracket set. So you'll see 8 is the only one that fits in that equation. So all I'm left with is just an 8. For our class, though, if you want to put it in variable form like that, that is okay instead of using the brackets. However, when you get to middle school, you're going to be seeing the brackets a lot more. So we're just exposing you to them today. Alright, let's work on our next problem. What numbers can I put in for m to make this true? Well, I'm going to look, since there's an equal sign, there's only going to be one right answer, so I'm going to do the inverse, plus 4, plus 4, and I'm left with m would equal 6. Do I see 6 up here at all? I see a 3, I see a 5, a 3, and 8, but I don't see a 6, so my answer should be none. Okay, let's try our next one. What numbers can I put in for m to make this true? Well, I know when I subtract, I'm going to have this expression. M is less than 8. Notice how even with the inequalities, I can still perform operations. Whatever I do to my left side, I do to my right. So I can still perform my math operations with the inverse. However, you're going to find out it is important that you check your work, that you make sure it makes sense, and we'll get to one of those later. So I'm going to be left with m is less than 8. Well, which one is less than 8? I have a 5, I have a 3, and I have a 0. So let's check. If I put a 0 in for m, is that true? 0 plus 4 is 4. 4 is less than 12, so it looks like my answer is correct. And then here I have those brackets again, just in case I don't want to use that variable expression answer. Okay, my next one. M minus 4 is greater than 2, so I'm going to do the inverse, plus 4, and I'm left with m, and then I add those two together. M is greater than 6. So what would I have? Well, my ones that are greater than 6. 8 is greater than 6, 10 is, and 14. They're all greater than 6. So I'd be left with 8, 10, and 14. Let's check that out, see if we are correct. There I am. Okay, let's try our next one. M times 0.5, or m times 5/10 equals 8. So let's check. I'm going to do my inverse. What is the opposite of multiplication? That's division. So I'm going to divide 8 off to the side by 0.5. I see my decimals on the outside, so I move that, and I move that. So now I'm left with 5 goes into 80 one time. Bring that down. Left with 16. So m equals 16. Do I see 16 up here anywhere? I don't. So I should have none for my answer again. Okay, my very last one. Then we'll go to our next page. M times 5/10 is greater than or equal to 8. Well, I just looked over here and I saw that m needs to be 16. Now I need my answer to be bigger than 16. So that means this number would have to be larger. Do I have any numbers over here that are larger? I don't. Just to check though, I'm going to see if 14 would work. So 0.5 times 14, 5/10 times 14. Well, I can't do that in my head, but I know this is 1/2, and I know 1/2 times 14, that's 7. And I know that 7 is not greater than 8. So again, I should have none for my answer. And there I go. Okay, my next one, give these problems a try. Choose the numbers, if any, that make the equation or inequality true from the following set of numbers. So we're going to be focusing on these. And let's check. If you do these in your head, that's fine. If you have to do the inverse, that is okay as well. What plus 5 equals 6? Well, I can subtract 5 from both sides, and I'm left with 6 minus 5 is 1. So I'm left with x equals 1. I'm going to do the same thing over here, and I see that 1 is there, so I'm going, okay. I'm going to have x, subtract 5 from each side. X is less than or equal to 1, so I'm going to look. Well, I have a 1, and I have a 0. So my answer, I'm going to use my little bracket, should be a 0 and a 1. Let's check those. It's x equals 1, it's correct. And that's 0 and 1 right there. Okay, my next one, I'm going to divide, do my inverse. So when I divide, those 5's cancel out. I'm left with y equals 40 divided by 5, which equals 8. Do I see 8 up here anywhere? Yeah, I do, right there. So my answer should be y equals 8. Then let's check over here. 5 times what is greater than 40? Well, I'm going to do my inverse again, and I'll be left with y is greater than 8. Do I see any of those problems or answers over here? Well, I see 8, but is 8 larger than 8? No. So if I put 8 in, would that be a true number sentence? 8 is larger than 8? It wouldn't be. So I'm not going to pick 8. I'm going to pick everything larger. 11 is larger, and 17 is larger. Okay, let's check these two. So y equals 8. Excellent. And then I should have 11 and 17. Perfect. Okay, my next one. 5/10 times y equals 5. What can I put in so that it's true? Well, I'm going to do my inverse again. I'm going to change this, though, to this problem, because for me it's easier. I know the inverse, the opposite of that, that is 2. And now I'm going to multiply my right side by 2, and I'm left with y equals 10. Do I see 10 up here? I don't. So my answer is none. Okay, my next one, I'm going to do the same thing. I'll notice this problem is the same as that, except for my operation, or not my operation, my equality or inequality. So I'm going to be left with y. It's less than, I'm just copying this exact same sign down, then 10. Less than or equal to 10. Do I see any of those up here? Well, I see 1, 2, 3, 4. Those are all less than or equal to 10. So I'm going to copy those down. And now let's check these two. Should have none. And I should have 1, 2, or 1, or 0, 1, 5, and 8. And look. So far, so good. My last one, k minus 3 equals 20. I'm going to do the inverse, so I add 3 to each side. I'm left with k equals 23. Do I see that anywhere up here? I don't. So again, my answer should be none, since I don't see 23 in these numbers they're asking me to use. My next one, I'm going to do the same thing. I'm going to copy this exact sign down the exact same way. Do I see numbers that are greater than 23? I don't. So again, my answer should be none. And let's just check just to make sure. Perfect. There is an easy way to do this if for some reason you can't. It just takes a long time. What you can do is you can put this number in for x and check. Is that true? 0 plus 5 equals 6. That's not true. Then you take your next number, plug that in. 1 plus 5 equals 6. That would be 6 equals 6. That would be true. And you can just keep going. 5 plus 5, that would be 10. 10 does not equal 6. And you can just keep going on down. It will get you the right answer. However, it's going to take you a long time. That's why I didn't show you till the very end. Alright, what you guys are going to do is you're going to log on to Socrative. Your room number again is Corbett 6. There's going to be 10 problems. If you answer 8 out of 10, then you may go to Khan Academy and work on that extra credit. If you cannot get 8 out of 10, then you're going to watch the video again and then go to Socrative again and take the test again. And hopefully you'll get 8 out of 10 this time. For those of you, we had some confusion on Khan Academy yesterday. For those of you who are doing Khan Academy, remember it is Wimbley for your login, Wimbley, and then you'll look on the website and it says number on our class links. It tells you your login is Wimbley number. You'll notice this is capitalized, number is capitalized. So what that's telling you is it's telling you to spell out your Wimbley with the capital, and you're actually going to spell out the number with the capital. So here's an example. Wimbley, and then 22. So since it's 22, I'm spelling out 20 with a capital T, and then that 2 with a capital T. So every single word, every new word starts with a capital. All right, good luck, and hope you do well on your assessments.